Okay, so let's see if you have the algebra skills to figure out and solve this interesting algebra word problem. Now, this particular word problem is a little bit challenging, so don't give up so soon if you are having a tough time with it. But let me go ahead and read the problem. It is as follows. Find a man's rate of walking if, by increasing his rate by 1/2 miles per hour, he can cover 30 miles in 2 hours less time. All right, so that is the problem. Feel free to use a calculator, but this is a multiple choice question. And let's take a look at our answers. And by the way, all of these answers over here are in miles per hour. So A is 2 miles per hour, B is 2.5 miles per hour, C is 3 miles per hour, and D is 3.5 miles per hour. All right, now if you have the answer, go ahead and put that into the comment section. I'll share the correct answer in just 1 second. Then, of course, we're going to walk through step by step, and there is a good amount of work to do in this particular problem. So I'm going to kind of get right to it. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. All right, now a lot of you may be confused about what the problem is saying, and that's totally understandable. Let's read it one more time before I show you the answer. So find a man's rate of walking if, by increasing his rate of walking by 1/2 miles per hour, in other words, he's going to speed up, he can cover 30 miles in 2 hours less time. All right, so let's go ahead and take a look at the answer. The correct answer here is B, 2.5 miles per hour. Now, if you got this right, you definitely get a happy face, an A plus, a 100%, and a certificate of excellence because indeed you are a certified professional expert in the area of solving an algebra word problem. And this is a pretty kind of classic or typical type of algebra word problem that involves motion. Okay, and what we have here really is a rate time distance type of problem. And these type of problems are an absolute must know for those of you that are studying algebra. Now, if you are confused, you're like, hey, Mr. YouTube Math Man, I'm totally lost. I'll never be able to figure this out. Well, don't lose hope because I'm going to walk through the steps right now. And even if you're pretty good at algebra, this is a little bit of a challenging problem. So let's go ahead and get into it. As I indicated, we have a good amount of work to cover. All right, so here is our problem. What should we do when we're faced with a lovely math word problem? Well, I kind of wrote down some steps here, but let's suppose you encountered this on some sort of an exam and you're like, all right, Mr. UT Math Man, I'm totally lost here. What should I do? Well, if you're saying, I'm going to guess, that is absolutely the correct answer. You always have some sort of a chance to get the right answer. And the only thing I would say on guessing on some sort of math exam or test is if you are going to get penalized for the wrong answer. And this can be the case on certain exams like the SAT or ACT. But other than that, definitely take a guess. So you're like, yeah, two looks pretty good to me. That's a fantastic guess. Unfortunately, it's wrong, but at least you took a chance, right? You got a 25% chance to get this thing right. So if you guessed and you got it right, well, that is fantastic. But if we didn't have a multiple choice question here, well, we're just simply going to have to know the math to figure this thing out. All right, so let's take a look at the steps to face, or the steps that we need to think about or kind of face when we are doing an algebra word problem. Okay, so here I kind of wrote a quick summary. So the first step, and there's 6 steps here. The first step, and these are kind of general guidelines, is read the problem at least 3 times. Okay, so get in the habit of reading the prompt and be like, all right, well, let me read it again and then read it again and just really make sure you absorb the information and most importantly, make sure you understand what the question is and then kind of give your brain an opportunity to kick in and start to kind of strategize about what to do. Okay, so you're just kind of brainstorming, taking in the information. So again, the worst thing you can do is simply read the problem one time. And a lot of people do this because they're in a rush, like, all right, I got it, I'm going to do this. And then they get confused and then they reread the problem again. So, math, a lot of things about math are forming good habits like being neat, taking your time, being structured, and reading problems more than once. All right, so after you read the problem at least 3 times, what you want to try to do is create a model of the problem. Now, we are talking about algebra, word problems, or math, word problems. So you want to try to visualize the problem if you can. And this is where one person's model may be different than another person's. That's perfectly fine as long as you understand it. And I think another good litmus test here is as long as someone else reading your work can understand your logic, right? So just be clear and neat and kind of model the information because if you can see the problem, visualize it, oftentimes that is the secret to figuring out, how to see the solution. Now, we are talking about algebra here, so what we're going to do is the next step here is we're going to select some variables. Now, what should our variable represent? Well, typically, our variable is going to represent the unknown value that we're looking to answer. In other words, what is the question, asking? Okay, it's asking, like how fast is this man walking? Well, maybe we'll let our variable x equal what the unknown value is, right? Because if we figure out what the variable is equal to, well, we'll pretty much answer the question. Now, in general terms, that's typically the best selection for a variable is to represent the unknown value that you're trying to answer in a question. But sometimes there can be some, subtle differences or some variations. But in general, that's what your variable or variables are going to represent. Now, once you have some variable expressions and these variables represent something in the problem, well, we can't figure out what those variables are equal to unless we build an equation. Okay, so you're going to have to use the rest of the information in the problem to build an equation. Now, what type of equation? Well, we can have all different types of equations. You can have systems of equations, quadratic equations, linear equations. You just don't know. Obviously, this depends on the problem. Now, once we have our equation, we're going to solve that respective equation. And then once we have the solution, and this is a big, big step that a lot of people miss. They'll like, okay, I solved the equation. I'm done. Here's the answer. Well, not necessarily so. Make sure that you are answering the question. And oftentimes you need to get the solution to the variable and then do like one more step to get the right answer. So really think it through until the end. But these are kind of the general guidelines that you should be following when you're encountering an algebra word problem. All right, so let's go ahead and get into this right now. And here is our problem. Now, I've already read it a few times, but it is confusing, or it may be confusing to some of you out there. So we have a man and he's walking, right? A man's rate here, R-A-T-E. This word basically is synonymous with speed or velocity. So basically, the man is walking at this particular speed. If he increases his rate or speed 1/2 miles per hour, he can cover 30 miles in 2 hours less time. So let's see if we can kind of make a sketch of this situation, something that kind of takes us from all these words to something kind of visual. So this is what I came up with. Now you can come up with something different, but here we have this man. And if he walks a certain rate over a certain period of time, he's going to cover 30 miles. All right, no big deal. But if he increases his rate, however fast he's going, he's like, you know what, I'm going to pick up my speed 1/2 miles per hour. Well, the time it takes to cover this 30 miles is going to be 2 hours less. Okay, so whatever time this is, he's going to save 2 hours less time covering this 30 miles if he increases his speed 1/2 miles per hour. So take a look at this little chart here, make sure it makes sense. Now, if you're saying, yes, Mr. YouTube Math Man, it makes sense to me. Well, of course I did this in advance, but you would have to think it through, like yourself, if you were just starting from the beginning, you didn't have a model, you have to think about it. All right, I got this person walking. Here's his rate. Here's the distance. So this will take a little bit of time, but a good thing to do is to spend or invest some good time to come up with a clear model, at least the best you can, that interprets or visually represents or graphically represents the information in the problem. Okay, so if this is pretty good for most of you out there, like, yes, I understand, Mr. YouTube Math Man. Well, let's move on to the next step because we are not done. We need to understand a formula. Okay, now, as I indicated in the beginning of this video, what we're talking about is a motion problem. Okay, very standard type of problem in math. And here is a formula that you must commit to your long-term memory. And that is rate times time is equal to distance. So, you're going to learn a lot of formulas in math and in science. This is why we take notes. Don't try to memorize everything, but this formula, yes, indeed, put it in your long-term memory. So again, what is rate? Well, rate is like speed or velocity. Okay, what is time? Well, time is time. And then what is distance? So let me give you a simple example. All right, so a car goes 60 miles per hour. Okay, so a car is traveling at 60 miles per hour, right? Kind of think about this for a second. Now, if it travels for 1 hour, okay, what is the distance that car is going to cover, right? So if a car is traveling 60 miles per hour and a car travels for 1 hour, how much distance did it cover? Well, if you're saying, hey, it covered 60 miles, Mr. YouTube Math Man, that is quite obvious. Well, indeed it is. And rates, okay, are comparing two different units of measure, all right? So really, that miles per hour, I can think of it this way, miles per hour, and we're multiplying by hours, okay? So right here, we really kind of have a fraction, 1 hour over nothing, and you can see that our hours cross cancel, and we're left with miles as our unit of measure. So rate times time is equal to distance. You gotta need to know, you must know this formula, but even more importantly, you need to be very aware of the units of measure involved here, right? So if we're talking about miles per hour, this is going to be our rate. So we want our time in hours, not minutes, not seconds, and we don't want our rate in miles per second. It's miles per hour. Now we can convert one unit to another, and sometimes you have to do that. So if we have our rate or velocity in miles per hour, and we multiply by our time in hours, then our distance will be in miles. Okay, so this is the way we're going to approach this. And because we are talking about miles in this problem, and I already kind of indicated that we're talking about miles per hour in terms of the answer. Well, these are the units that we're going to be thinking about. All right, so let's go down here and kind of take a look at our lovely chart again. Now, knowing about rate times time equals distance, we want to think about our chart, but we want to kind of upgrade it a bit here. So our rate will be in specifically miles per hour, and our time here will be in hours. All right, just to be super clear. Okay, so we're getting, kind of started here. A lot of you are saying, well, Mr. YouTube Math Man, we haven't even done anything. I know we haven't even selected a variable. As I kind of, again, told you in the beginning of this problem, this particular problem does take some time to think about and solve. All right, so now let's go ahead and select some variables. So this will be our next step. So here we have our formula, rate times time is equal to distance. So let's let x equal the rate, okay? The slower rate, not the rate that the man is traveling when he picks up his speed. This is kind of like the baseline rate, okay? So this is his rate going slower. So we'll call x that rate, okay? Now, again, we're going to establish that the unit of measure for this rate is going to be miles per hour. All right, now what we're going to do is construct a table, okay? And in algebra, when you have word problems, very often you want to construct a table. This isn't the only way to kind of set up a solution to a word problem, but it's a fantastic approach, and it's one that I would highly suggest. Okay, so here is our formula, okay? It's rate times time, so this is multiplication. Here, rate times time, and that's going to be equal to distance. So let's think about the information that we know in this problem so far. So we know that this man is traveling, at his base rate, and then he's going to pick up his speed. So he starts off at X miles per hour. That's his rate here. And then he's going to later pick up his speed at X, whatever he was traveling, and then an additional 1/2 miles per hour. So we have two different rates. Now you'll see where I'm kind of going here in a second. Now the distance that he's traveling is both 30 miles, whether he's going slow or he's going a bit faster, 1/2 miles per hour faster, he's still covering the same distance, 30 miles per hour. Now, what is going to be different here is the time, right? So this time is going to be longer, obviously, right? Than because he's going slower, and this is going to be a faster or shorter period of time. So how can we express time given that we have x here and 30 as our distance? We have an equation or we have a formula, rate times time is equal to distance. How can we express time when we have the rate and the distance? Well, we need to use some basic algebra, and let's go and think about that right now. All right, so here's our formula. Rate times time is equal to distance. So we have rate and we have distance, like in this example right here. We can solve for time, t, by dividing both sides of the formula by r. So time can be expressed as, or time is equal to distance over rate. Okay, so this is the way we can express time. So over here, we can express our time as distance over the rate. Okay, so we have the distance, we have the rate, so we can kind of use these two values right here to plug in for our respective times. All right, so let's go and do that right now. And just to be extra clear, our rate again is in miles per hour, our time is in hours, and our distance is in miles. So we have the slower rate, the base rate of x, miles per hour. He's going to travel those 30 miles, but he's going to do it in distance over time. So in this case, it's going to be 30 over x. All right, so that is this row right here. And then we're going to use the same logic to figure out the time. But here's the thing, okay? For this particular entry, for the time when he picks up his speed, remember the problem says he can cover this distance, this 30 miles, in 2 hours less time. So if this is his normal time walking slower, he can cover it 2 hours less time, right? So we just take away 2 hours from this time, and that is the time it takes him going at this speed. All right, so obviously we're going to have to really think about these entries and why are we doing this, okay? Some of you might be saying, hey, Mr. YouTube Math Man, I don't even understand why we're building this little table out. How are we going to figure this thing out? Well, let's think about this again. So rate times time is equal to distance, okay? Well, he's going to cover the same distance whether he's going slower or faster, right? But rate times time is equal to distance. So this right here, this expression, x times 30x, is the same as 30, okay? It does represent this distance of 30. And so does this right here, x plus 1/2 times 30 over x minus 2 also is equal to 30. So we can set up an equation here because this is equal to this. These two products represent the same distance of 30. Okay, so hopefully you're not too confused, but now we can set up an equation to solve for x because again, we have our variable, we needed some information to figure this out. So here is kind of the way you can think about it. All right, so x is what? This is the slow, well, let's kind of label it this way so you can really understand it. This is him going slow, okay, or his base rate, and then here is him going faster, 1/2 miles per hour faster. So if he goes this slow rate, okay, he's going to travel this time, 30 over x, he's going to cover 30 miles, this distance. And this times this is his rate when he goes 1/2 miles per hour faster, times this time, which is 2 hours less than the normal time, it's still going to be 30. So really what we have here is 30 is equal to 30. So this is an equation. And now this really comes down to your ability to solve for x. Wow, this is a lot of work, right? Some of you might be saying, Mr. YouTube Math Man, this is why I don't like algebra. Well, listen, I can totally get that, but don't give up because we are almost there. But before we finish out this problem, I need you to go ahead and hit that subscribe button. Now, I can tell you right now, and I know I say, I kind of ramble sometimes in these videos. I apologize for it because I do make a lot of videos. My mind sometimes is all over the place because I just love teaching math. And I'm thinking to myself, boy, someone may need help in calculus. Maybe someone needs help in basic math, or geometry. I'm all over the place trying to help everyone because I love teaching math and I don't want anyone kind of left behind in terms of if I have something to offer them. So sometimes, I get a little bit scattered in these videos, but I am consistent. At least I try to be, and I've been consistent over many years posting math videos. And my aim is always to try to explain, these concepts in a clear and understandable way. So hopefully, my instruction is resonating with you. And if you're like, yeah, you're not too bad, Mr. YouTube Math Man, well, hit that subscribe button. It really, really does help me on YouTube. It helps me reach other people, and that is my mission. And if you're going to do that, hit that notification bell as well so you can get my latest videos. All right, now some of you may look like this at this point in the problem, and I love doing these little crazy happy faces or little sketches. Some of you might be like, all right, already so far, Mr. YouTube Math Man, I got smoke coming out of my ears. Well, listen, we're not done because it's going to get much, much worse. So that's going to even make some of you like scream, oh, no, no, don't do this. Well, yeah, we're going to have to solve this equation, which is a challenge in and of itself. All right, so here we go. And if you're having trouble with any of the algebra or anything in here, check out like my Algebra 1 or Algebra 2 courses. You can find links to those in the description of this video. Also, if you love solving word problems, I have a ton of additional word problems on my channel. All right, so we need to do a bunch of work here to solve for x, so let's go ahead and get started. All right, so we have x times 30 over x. The x's cross cancel, so we have 30. Again, I'm going to be going a little bit fast, so if you need to stop the video and think about it, that's perfectly fine. All right, so we have x plus 1/2, and we're going to multiply this by 30 over x minus 2. Okay, so we have a binomial times a binomial. So let's use the FOIL method here, first, outer, inner, last, or any other way that you know to multiply a binomial times a binomial. So x times 30x is 30. All right, so x times negative 2 is negative 2x. 1/2 times 30 over x is going to be 15x. Okay, and then 1/2 times negative 2 is negative 1. Again, if you have any difficulties with what you're seeing, you know where to go to get extra help. Okay, so at this point, what we want to do is set this equation equal to 0. So I can subtract 30 from both sides of the equation. And when I do that, I'm going to get a 0 over here. And this isn't really going to help us out. So the 30s go away, and I'm left with negative 2x plus 15 over x minus 1. Okay, so this is what we have right here. Now, there's a number of different kind of approaches you can take, but really we're cleaning up this lovely equation. All right, so we have 0 equals negative 2x plus 15 over 1. So now let's go ahead and move this 1 over to the other side. So we'll add 1 to both sides of the equation. So now we have the variables on one side and the numbers on the other side. So at this point, we have a fraction right here, 15 over x. Again, different approaches you can take in terms of the algebra, the mechanics of this problem. But if you don't like working with fractions, one of the best things you can do, and let me go ahead and make this clear what the denominators are. So we have 1. Here is 1, and then here is our denominator of x. So you can clear the fractions in an equation by multiplying by the lowest common denominator. In this case, 1, 1, and x. The LCD is x. So you don't have to approach it this way. You can add these terms. That's perfectly fine. But I'm going to go ahead and multiply everything by x right now. Okay, so when we do this, I'm going to get x times 1 is x times negative 2x is negative 2x squared, and then x times 15 over x is 15. All right, so it looks like we're looking at a quadratic formula because we have an x squared here. So let's go ahead and work on solving this. I know a lot of you are like, boy, this problem is crazy. All right, so continuing on, we're solving quadratic formulas. Well, it looks like we have a trinomial here. We have an x term, we have a number. So let's set the entire thing equal to 0. So this time I'll move the negative 2x squared on the left-hand side. I think I was saying the negative 2x. If I misspoke, I apologize. All right, so we're going to move the 15 over to the other side with x. So if you don't understand what I'm doing here, again, I'm just simply adding 2x squared to both sides of the equation. That's going to give me 2x squared, and then I'm going to subtract 15 from both sides of the equation. So you're going to end up with this. All right, so we have 2x squared plus x minus 15 is equal to 0. All right, now at this point, we're thinking, okay, we have a quadratic trinomial. Is it possible? Can we factor this thing? Hopefully we can, and indeed we can factor if you know how to factor quadratic trinomials, which is a skill in and of itself. But this can be factored into two binomials, and again, if you're struggling with factoring or anything else, you got to learn this stuff. All these things that I'm doing right here is like baseline skills for like first year algebra. All right, so if you're like, wow, I can't do this, or this is, difficult, and you have to learn this stuff, well, you need to follow through. Okay, so hopefully you understand how to factor. But 2x squared plus x minus 15 factors into these two binomials here. 2x minus 5 times x plus 3. Now we have two factors. We have this thing being multiplied by this thing is equal to 0. See, this is why we love to set equations equal to 0, because if we can factor, we can use the zero product property, because this thing times this thing is equal to 0. So if this times this is equal to 0, then that means that one or both of these things must be equal to 0. So we're going to set each factor equal to 0 and solve. All right, so 2x minus 5 is equal to 0. We do all the lovely algebra. We get x is equal to 5 halves, which is the same thing as 2.5 miles per hour. And then over here we have x plus 3 is equal to 0. X is equal to negative 3. But take a look at our sign. This is negative, so we're not dealing with negative miles per hour. So we can throw this solution out in this quadratic equation, and we're left with 2.5 miles per hour. Now, one step that I'm not showing you here, but I do want to mention it, is anytime you multiply, okay, both sides of an equation by a variable, okay, x, it's possible you can introduce something called extraneous solutions. So really, technically, I would want to check this solution 2.5 miles per, or 2.5 or 5 halves in the original solution, and it will work out. So that is a mandatory step, but I'm going to skip it for this video. I do need to tell you about it because it is a mandatory step, but it does work out, and the only reason I'm going to skip it is because we've had enough fun, and maybe some of you kind of look like this right now, and definitely don't be like, I'm not smart enough, I'll never understand this. Well, listen, this particular problem is a bit challenging, but it's, if you do a problem like this, if I said, hey, just focus on this problem, struggle with it, do it again, do it again. If you did this problem like 3, 4, 5 times, you will get how to do this problem all on your own. So you're not going to master math, algebra, geometry, trigonometry, calculus, whatever the case is, without paying a certain price in terms of effort, right? It takes a lot of practice. I don't care how smart you are, you have to practice, 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 because math is a skill. All right, so with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.